In this video, I'm going to be discussing how to solve trig equations. Now, I'm going to start by looking at some basic examples of trig equations, and then we're going to look at some more complex examples and some tips of how to deal with them. Now, this is a basic example of a trig equation right here, where I have cosine of x equals -1. So if you notice that the variable is inside of the trig function, meaning that what I'm trying to find is I'm trying to find an angle. That's ultimately what I'm looking for. So in this particular case, I'm trying to find what angle gives me a cosine of -1. Now for this particular problem, we're solving between the interval of 0 and 2 pi. Now notice that is just a full rotation of our circle. We start at 0 inclusive, remember the bracket means inclusive, going all the way to 2 pi, not including 2 pi. So back to the problem, it says that cosine of this mystery angle is -1. Now if I'm looking at my unit circle, remember that the x-coordinate tells me the cosine of that angle. So if I'm looking at, for example, 0, the coordinate is 1, 0, meaning that cosine of 0 is 1. So I'm going to use the unit circle to make my life a little bit easier. So I'm going to find the angle that has a cosine of -1. Now scanning around my circle, I see right here, let me circle that, right there, my x-coordinate is -1. So this angle is pi. Now if I look around at the rest of my x values, I don't see any others that are -1. So my only solution to this problem is pi. Let's try another one. So I have cotangent of x equals square root of 3. Now just a reminder that cotangent is the same thing as sine over cosine. Or sorry, cosine over sine, let me get that right. Cosine over sine. So essentially I'm going to look for the trig functions. When I take cosine divided by sine, it gives me positive square root of 3. Okay, so taking a look here, I see that my first answer is right here, is pi over 6, because cosine here is square root of 3 over 2, and my sine is 1/2. Now just a refresher, when I would divide, so if I were to divide square root of 3 over 2 and divide it by 1/2, we would multiply by the reciprocal, so square root of 3 over 2 times 2 over 1, and the 2's cancel, giving me square root of 3. So my first solution is x equals pi over 6. My second solution, let's see if I go around, I see my next one is right here. Because they're both negative, so a negative divided by a negative is a positive. So my other solution here is 7 pi over 6. It is very possible, and not likely all the time, that you're going to have more than one answer. You typically will. That is why we limit our answer between 0 and 2 pi. If you remember that all angles have an infinite number of coterminal angles. So if I didn't put the original restriction between 0 and 2 pi right here, I would keep having an infinite number of answers to this one question, which gets a little annoying to write. So my only solution here, pi over 6 and 7 pi over 6. Let's try another one. So here, I've got sine of x is square root of 2 over 2. So I'm trying to find the angle that has a sine ratio of square root of 2 over 2. So I'm going to look up here at my unit circle. Again, I'm going to look at the y's, and I see, okay, there's one right there. And so this angle is pi over 4. So there's my first one, pi over 4. And I'm going to keep looking. All right, looking around my y's. There's another one. And so my other angle is 3 pi over 4. 3 pi over 4. Now if I look down in the third and fourth quadrants, I know I'm not going to have any answers because sine is negative in the third and fourth quadrants. So I can stop after the first two quadrants and move on. Let's do one more. Let's do secant. So secant of x equals 2. Now, just a refresher again that secant is the reciprocal of cosine. So I'm basically going to be looking for when is cosine equal to 1/2. So looking at my unit circle, all right, starting here, all right, I've got one right there. Cosine is 1/2. So my first solution is pi over 3. And let's go back and scan just a little bit more. So let's see, all of these x's are negative, so these aren't going to work. And I see there's my next one. And so my next answer is 5 pi over 3. 5 pi over 3. And I don't have to go any farther than 2 pi because of my original restriction, where I say don't go past 2 pi. So those are basic trig functions. Now let's take a look at some more complex examples. So here I have a couple more complex examples. Now as I have these complex examples, I'm going to present you with a strategy. So the first strategy when you're given more complex trig equations is to first get the trig function alone. Isolate it like you would isolate, for example, 2x plus 1 equals 5. Think about using inverse operations to isolate the x. We're going to do the same thing to isolate the trig function. Now again, we're only going to solve between 0 and 2 pi, so nothing crazy. So let's start with the first one. So here, I'm going to start by getting the cosine by itself. So I add 1, so that gives me 2 cosine x equals 1. Then I'm going to continue isolating, divide by 2, so that gives me cosine x equals 1/2. So now I have to figure out what angle gives me a cosine value of 1/2. Now conveniently, we did this on the last problem. If you remember down here, we already did that. That's pi over 3 and 5 pi over 3. So my solution to this particular equation are pi over 3 and 5 pi over 3. So let's try the next one. So the next one here, I have cotangent squared. Now we do know that this has a trig identity, but we'll get to those later. What I can do when I have a trig function squared is take a square root. That's perfectly fine. Now the big thing to remember when you are taking square roots is that you have to include a plus minus in your solution. So square root of 1 we know is 1. So I need to look for all of the angles that have a cotangent value of positive or negative 1. Now hopefully these angles kind of pop out. Remember that cotangent is the reciprocal of tangent, and well, it doesn't make a difference in this question because it's both 1. So all of the trig or the angles that have a cotangent value of 1 are pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And the way I can confirm that is if I back up to my unit circle. Remember, cotangent is cosine over sine. We covered that. I just have to look and see when are they the same. Cosine over sine is 1. Okay, there's my first one. Next one is the negative. And so on all the way around the circle to get my 4 possible solutions. Now let's try the last one. So for the last one, I have 1/2 times sine of x equals 1. So I need to get rid of this 1/2. I'm going to do so by multiplying both sides by 2. And so what I get here is I get sine of x equals 2. Now I have to figure out what angle gives me a sine ratio of 2. Well, if you look at the unit circle, the highest sine value I have is right here at 1. There is no such thing as sine of an angle giving us 2 because our unit circle is limited to 1. Since that is the case, it is impossible for us to get an angle that gives us a sine of 2. So we say no solution. Let's take a look at the next tip. So when appropriate, use identities to get just one trig function. Now the example below is going to illustrate what I'm talking about. So here I have a more complex trig function, and I see that I have multiple trig ratios. I have a sine, I have a cosine. What I'm going to try and do is get this all in terms of one trig ratio. Now it doesn't matter if I get it all in terms of sine or in terms of cosine. So what I'm going to do is I'm actually going to get rid of the cosine. And I'm going to do that using this identity. Remember that cosine squared is 1 minus sine squared. That's a trig identity. So I'm going to do a substitution here. So I have 3 sine squared x minus, and then in parentheses, 1 minus sine squared x equals 0. Then I'm going to distribute my negative, so 3 sine squared x minus 1 plus sine squared. Now by doing this substitution, I have gotten this all in terms of sine squared, which should make it a lot easier for me to work with. So let's see, I'm going to go ahead and combine my terms. So that gives me 4 sine squared x minus 1 equals 0. Just combine my terms. Then I'm going to isolate like in the previous step. So I add 1 to both sides. So I have 4 sine squared x equals 1. Divide both sides by 4. So I get sine squared x equals 1/4. Now again, like on the previous slide, I have a square root. So I have a squared, so I'm going to use the square root. Now like before, I'm going to include a plus minus. So what I'm left with is I have sine of x equals plus or minus 1/2. So what I have to do is I have to find all of the angles that give me a sine ratio of 1/2 or negative 1/2. Now I know there are going to be 4 answers to this, and those are pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. All of these either give me a sine value of positive 1/2 or negative 1/2, and you can use your unit circle to confirm it. For the next tip, if you can't get the equation in terms of one trig function, you need to try factoring. Now this is a concept that we covered in the previous sections, but it's something that's going to come up again. So for example, here I've got sine squared x plus sine x minus 20. Now the only way I could substitute here, well I could do multiple substitutions, but nothing's really going to help me here because it's already in terms of sine. So what I'm going to do is factor. Now let's consider something like this for a moment. Plus 1x minus 20. I know that this factors to be x plus 5 times x minus 4. Just using the old techniques. We're going to do the same thing here. So when I factor, this becomes sine of x plus 5 times sine of x minus 4. And that equals 0. Now, similar to what you had to do in Algebra 2, you do need to get this equal to 0 if it's not. But since it already is, I'm great. Now, just like if I were to solve an equation like this, I have to set each of these equal to 0. So sine of x plus 5 equals 0. And sine of x minus 4 equals 0. There we go. And I solve each of them respectively. So subtract 5 from both sides, so that sine of x equals negative 5. And this one, add 4, I have sine of x equals 4. Now again, I have to try and find an angle that gives me a sine value of negative 5. Now if you look at your unit circle, doesn't exist. There's no such thing. So this does not give me a solution. Same thing on the other, I have to find an angle that gives me a sine value of 4. Doesn't exist. So since neither of these work, we say no solution. Now other times it'll work out, just in this case it didn't, which is possible. Now let's look at the last tip. The last tip, if there is a number with the angle, ignore it until the end of a problem, then work with it. And so the answer below, or the equation below here, is going to illustrate what I'm talking about. So remember that x is an angle, the thing we're trying to find. So in this problem here, I have x over 2 inside of the sine. Now basically, here's what I'm going to do. I'm going to solve this as if it were sine of x equals 1. That's what I'm going to try and do. Now in this particular case, what I know is that this is pi over 2. Okay, I know that sine of pi over 2 is 1, so that's the angle I'm looking with. Now to deal with this x over 2, what we do is we take this pi over 2 and we do this. We set them equal over pi over 2. And so that way, I can account for this divide by 2. Now solve, so multiply both sides by 2, and I get x equals pi. Now if you want to think about why does this make sense, just plug it back into the original equation. If I were to replace x with pi, I would have sine of pi over 2. And what is sine of pi over 2? It's 1. You can use your unit circle, evaluate this trig function however you would like. Now that is the beginning of how to evaluate or to solve trig equations and some tips on how to solve some more complex equations.